Okay, let's dive right into this explainer. We use AI tools literally every single day now, whether it's to write some code, summarize a long chain of emails, or just brainstorm ideas. But have you ever stopped to wonder what the invisible journey happening in the background looks like the second you hit enter? Well, today, we're opening up the engine to look directly at the mechanics under the hood of large language models.
It really all comes down to one absolutely fascinating question. How does an AI actually understand you? Imagine you're texting a Marvel-level superpowered friend, someone who has perfectly absorbed every book, Wikipedia article, and digitized document ever written in human history. That massive, all-knowing digital brain is exactly what we're going to be exploring today.
So, by definition, a large language model, or an LLM, is an advanced AI system that learns patterns from massive data sets to predict the next token based on context. To put that into perspective, think of it as a massively scaled-up, hyper-powerful version of your smartphone's autocomplete feature. But instead of just clumsily guessing filler words like your phone does, an LLM uses incredibly complex math to generate entirely new, perfectly coherent thoughts.
And when we say large, we mean staggering. It's almost hard to wrap your head around. If you sat down right now to read through all the text data these modern models are trained on, and you read 24 hours a day, 7 days a week, with absolutely zero breaks, it would take you roughly 7,600 years. Crazy, right? So how does an ocean of data that deep actually build into a working system?
Well, let's track the journey of a prompt to see how this actually works in practice. When you ask the AI a super simple question, like why is the sky blue, it instantly triggers a 4-step journey. We go from the prompt to tokenization, then embeddings, and finally the transformer.
Let's start with the prompt and tokenization. Here's the thing, these models are completely blind to English letters the way you and I read them. They just don't see them. So our sentence, why is the sky blue, gets sliced up into smaller, easily digestible chunks called tokens. Now these can be full words, they can be syllables, or even just punctuation marks. It's the absolutely crucial first step in turning our human text into machine math.
Which brings us nicely to embeddings. Once we have our tokens, they have to become math. I want you to picture a cinematic, sprawling 3D landscape right now. The token for the word cat gets converted into a numerical vector, basically a long list of numbers like 0.21, -0.45, and so on. And these numbers, they act exactly like geographic coordinates in a massive multidimensional space.
Think of it just like this, a sprawling digital universe. Because these tokens are converted into coordinates, words that have related meanings organically cluster together in this mathematical space. So words related to cat, like feline or kitten, will literally be geographically closer together in this digital map than a completely unrelated word like car. So what just looks like numerical gibberish to us is actually a beautifully organized, perfectly clear 3D map of human language for the AI.
Now, to process all of those coordinate numbers at the exact same time, we enter the transformer. This is a dynamic 3D web of billions of digital neurons firing all at once. This is where the model moves way beyond just identifying words to actually understanding them. And it's all powered by an architecture introduced in a revolutionary 2017 research paper called Attention is All You Need, which fundamentally changed AI forever by ending linear processing. To really get why linear processing, reading left to right just like we read a book, was such a massive roadblock for early AI, let's look at a simple 7-word sentence. I didn't say he stole the money. Human language is incredibly subtle. If I shift my vocal emphasis to the word I, well, the meaning is that someone said it, but it wasn't me. But if I emphasize the word he, the meaning shifts to someone else entirely being the thief. Early linear AI models completely failed to grasp this kind of nuanced human context because they processed one word at a time and just lost the plot. They desperately needed a way to look at the whole picture all at once. And that brings us to the magic of self-attention. Think about this sentence. The animal didn't cross the road because it was tired. Self-attention allows the transformer to look at the entire sentence at the exact same time. It calculates how every single word relates to every other word simultaneously. So self-attention is the math that tells the AI that the word it specifically refers to the animal and definitely not the road. It pays attention to the exact right context. So the crucial point is what happens next. After navigating that massive 3D neural network and understanding the deep context, the system's ultimate goal is surprisingly simple. It just needs to guess the most logical next piece of the puzzle. The AI doesn't just confidently pick a word out of thin air, though. Instead, it assigns probabilities.
If the context is the sun rises in the model calculates, okay, there's a 70% chance the next token is east, a 10% chance it's morning, a 5% chance it's sky, and so on. It samples from this exact list of percentages to select the absolute best fit. The really remarkable part here is that the model does this for one single token at a time. It calculates probabilities, selects the best token, generates the text, and then, here's the kicker, it loops that new information right back into the system to run the entire prediction all over again. It repeats this rapid loop millions of times until the entire response to our original prompt, "Why is the sky blue?" is completely generated. Now let's zoom back out to the real world for a second and look at how this connects to the tools we actually use. There is a pretty major misconception out there that we really need to clear up, and establishing this exact hierarchy helps immensely. Artificial intelligence encompasses machine learning, which uses deep learning, which leads to transformer models, which power large language models, and finally, at the very end of that long chain, are AI applications, like ChatGPT. A lot of folks actually think ChatGPT is the LLM itself, but we really need to differentiate the two. The LLM is the massive underlying predictive engine doing all that crazy 3D math we just talked about. ChatGPT, on the other hand, is simply an application. It's a highly refined user interface wrapped perfectly around that engine so that you and I can easily interact with it. And this brilliantly illustrates a vital distinction between a traditional search engine and an LLM. A search engine goes out, finds existing documents, and ranks them. An LLM strictly predicts the next logical token. Understanding this is huge because it explains why language models can sometimes generate very confident yet entirely incorrect information. They aren't recalling facts from a digital file cabinet, they are mathematically predicting patterns. By turning language into numbers, scaling across billions of parameters, and capturing incredibly rich context, we have built a system that sounds shockingly human. As these digital brains continue to grow even larger and more efficient, what will they predict next? We are literally standing on the edge of a new technological frontier, and hopefully you now have a much better understanding of the brilliant mechanics hidden right under the hood of the AI you use every single day.